Crawford County Computer finds Crawford Computing, there we go, county, finds its weekly profit in dollars for the production and sale of X laptops is given by that profit equation. They currently sell an average of 9 laptops per week. What's the current weekly profit? So A is just asking you for profit at 9. So take 9, plug it into that profit equation. It's a dollar amount. And so when I take my profit at 9, it comes out $4,572.78 when 9 laptops are sold. All right, so that's no calculus, that's just algebra. All right, B also just how much is profit drop? All right, so how much do we drop if they sell one less? And so I actually want the difference. All right, I want to know how much does profit decrease when they only sell 8? So that's the current level. So I have to take 8, plug it into the profit equation, and then find the difference between that and 9. All right, so first I'll find 8, profit at 8. Comes out 3978.75, and then the difference, so it does drop, 3978.75 minus 4572.78, meaning it comes out negative 59403. So they have a loss of $594.03. All right, profit went down by almost $600. So A and B, no calculus yet. That is just algebra. C is the first calculus question. All right, what is the marginal profit at $9? And then interpret it, right? It's always interpret it, do the analysis part. All right, so marginal profit is the derivative of profit, right? Marginal profit is the slope, how much is increasing or decreasing by. So I find the derivative of my profit equation. So I gotta go back and look at my profit equation. So negative 0.012 x to the second minus 0.6x plus 600 if I look off my sheet I have here. Double check, make sure. 0.6, yeah, okay. So there's my derivative, my marginal profit. And then we wanted to find it at 9, their current level of production. All right, so my derivative at 9. So I take 9, plug it into my derivative equation, which again, that gives you part of the problem. This comes out 593.63. And again, my rule of thumb with dollar amounts is typically, unless they tell me I round to the penny. All right, so that's step 1. That's maybe a point, but the bulk of the problem is the explanation, right? The analysis, right? It's marginal analysis. So it's your analysis of the numbers. That's the important part. All right, so profit will increase by about $593.63 when they sell the 10th laptop, right? From 9 to 10. That specific jump, right? They're currently at 9. This is the about how much more it's growing by if they sell one more. All right, so it's the additional profit from the sale of one more laptop, and the one more specific. It's from 9 to 10. If I went from 8 to 9, I'd be different. If I went from 5 to 6, it would be different. If I went from 10 to 11, it would be different. It'd be slightly different, but it still would be different. So it's specific to that growth. I believe there was one more part to that. All right, use your previous answer to estimate the profit if they increase sales to 10. All right, so we're now going to use, what's the profit at 10? Well, it's approximately the profit at 9 plus the additional profit using marginal analysis. So the profit at 9, which I have all those, I don't have to do any more plugging in. The profit at $9 was our, here for part A, $4,572.78. The additional profit was approximately that number, 593.62. Add those together, and that should give me the approximate amount they would make in profit if they sold 10 laptops instead of 5, so they should make about $5,166. And again, it is an approximate. My little squiggly lines here means it's a good guess on what it will be. It's not exact. So when they sell 10 laptops, they will make about approximately an estimated amount, $5,166.41 in profit. All right. So again, keywords. What level are they producing? What's the next one, which is 10? It's an increase, and you should have some form that it is an approximation. It's not an exact answer. It's important that it's an approximation. All right, I'm going to go ahead and do the last example. So this one is not in your guided notes, but I wanted to show you that you can actually do this with any type of economic problem. Actually, you can do this with any problem, whether it's economic or not. So I'm doing an example of productivity. I'm going to do marginal productivity. You could do marginal supply, marginal demand. Again, there's a lot of, you can even use this with populations. The marginal change in population, if you wanted to, the marginal analysis and population growth. We typically stick to cost, revenue, and profit, but we don't have to. We're not restricted to that box if we don't want to. All right, so this is an example of marginal productivity. All right, so we have a small economy where the gross domestic product, the GDP, is approximated by the function. So G of x, which is 625x to the 0.2, is the gross domestic product. Again, it's how much money is generated in the economy. I mean, that's what gross domestic product is. All right? In the United States, we're in trillions of dollars. All right, so this will be a smaller little country or smaller little economy where it's in billions of dollars. Right, usually it's based on how much money is spent on capital and labor and materials and things like that. We're going to keep it simple. We're just going to look at the capital part. Capital would be investing it in properties, rentals, and things like that, and machinery and things like that. So this is the amount spent on properties, buildings, machinery. That's what the capital is. All right, so X represents the billions spent on capital. All right, find the marginal productivity. So marginal productivity is the marginal analysis of this productivity, marginal analysis of the gross domestic product. Marginal productivity is the derivative. All right, so I find the derivative of my productivity function, right, which in this case would be my 625 times my 0.2, x raised to the negative 0.8, right? 1 minus 0.2 is negative 0.8. And I'll simplify that. I'll take my 625 times my 0.2, so that comes out to my derivative. My marginal productivity, which is my derivative, comes out 125 x raised to the negative 0.8. All right, we want to know if we increase the amount spent on capital, which is the x value, from 21 billion to 22. So my 1 unit is actually a big unit. I'm going from spending 21 billion to 22 billion, but it's still a unit of 1. 1 represents 1 billion. And so my current x level is 20, right? So that's what I plug in. That's my current level. And so I find my derivative at 20. I plug 20 into that equation. So I take my 125 times 20 raised to the negative 0.8. It comes out 11.3785. All right, and now it's the analysis part. What does that mean, right? Explain your answer in terms of marginal analysis of the productivity level and the GDP. All right, so if they increase the amount spent on capital specifically from 21 to 22 billion, that specific billion, if I picked a different billion, I'd get a different answer. All right, so specifically that extra billion spent from 21 to 22. The gross domestic product, the amount of money the economy generates, that's what the gross domestic product is, increase and have an additional amount, however, but there should be some type of word that's indicating it's going up by approximately $11.3785 billion. Right? Which again, you could probably round a little more than what I rounded there. But that's a pretty good growth, right? They're just adding $1 billion more, specifically 21 to 22. If they add that one more billion into capital, they should produce a little over $11 billion more in economy dollars. All right, that's how much more the economy will grow by. Again, it is an approximation, so it should say in there that this is just a good guess based on our numbers. This is just a good guess, but this is what it should grow by approximately, and it should be within the ballpark. Right? It should be close to that number if they actually did that. But it is no guarantee because it's an approximation. All right, that finishes up. We're all done with Chapter 3. That finishes up marginal analysis. We will stop there and hopefully get ready for the unit exam.